Good morning all. So the first question, till now we are discussing on the welded connection. So one more question or one more portion is remaining in the welded connection when the load is unsymmetrical. Till now what we have studied was the load was symmetrical, that is the load is being applied to the center of gravity and the center of gravity lies exactly at the mid of your element. Now here you are going to see a tie member consists of IS angle 80 by 50 by 8 meter. This ISA means IS angle, okay. It is welded to a 12 mm thick gusset plate at site. Design the weld to transmit the load equal to design strength of the member. That is, you are given like this. It consists of a gusset plate and you are connecting an IS angle in this way. You are connecting an IS angle in this way. You are asked to find how much length of weld is required over here and how much length is required over here if I am applying a pull like this. If I am applying a pull like this. Okay, so how much amount of weld should I keep here, should I provide here such that if I am applying a pull like this or a tensile force like this, it will be safe. And this tensile force is the design strength of the member. How much design or how much this can carry, how much this angle section can carry, that is the thing we need to design, or we need to design that much load is to be designed. So is it okay? So can you tell me what is the design strength of the member? Can someone tell me what is the design? You have studied this while you are in your first series test. Can you tell me what is the design strength of the member? The design strength of the member will be in TDG, right? That is AG Fy by gamma m naught. You are familiar with this one. Someone please reply. I can't understand whether you are hearing or not. That's the thing.
Yes, sir.
You know this value, right? This is the design strength of the plate in yielding. That is TDG is equal to AG Fy by gamma m naught, isn't it? So Ag means what? Till now you have studied of a single plate element, that is width into thickness was your Ag. Now you are dealing with an angle element. This is IS angle, right? And the designation of this IS angle is 80 by 50 by 8. That is, it is having one leg is having 80 mm thickness, the other leg is having 50 mm thickness, 50 mm length, and the thickness of this angle section is 8 mm. That is, this thickness is 8 mm. This thickness is 8 mm. So you are able to understand the dimension of this one, right? This IS angle 80 by 50 by 8 means 80 mm length over here, 50 mm length over here, and the thickness is 8 mm. So you need to find the gross area. That is, what is the gross area of this? And what is the Fy value? What is the Fy value? Fy value is, this Fy value is, it's not given, so we can assume this value as 250 Newton per mm square. We will assume 250 Newton per mm square as the Fy value, Fy value, that is the yield strength of the plate element. And gamma m naught is what? From table number 5, you will get this gamma m naught as 1.1. So the only unknown here is Ag. That is the gross area of this angle section, isn't it? Now we will go to one thing, that is, there is a thing called a steel table. Do you remember I had given the steel table to you? At the beginning I told you you need to keep this thing, steel table. It is available in the Google Classroom. I have provided there. So in the steel table you could see, can you see this?
Yes, sir.
The steel table you could see the different contents like rolled steel equal angles, rolled steel unequal angles, steel T-bars, steel beams, steel channels, etc. That is, the properties of these things are being provided here. The properties of this angle section, equal angle section. Equal angle section means the length of this leg and this leg will be same. So here you are given IS angle 80 by 50 by 8, which means this angle is an unequal angle. There is one leg is 80 mm and the other leg is 50 mm, which means this is an unequal angle section. So you need to go here, you need to go down. This is also equal angle section, rolled steel equal angle. This is also equal angle. So here comes rolled steel unequal angle. The designation as A by B, that is ISA 30 by 20, 40 by 25 goes like this. Ours is 80 by 50, which means here it is 80 by 50, and the thickness here, see here, there is IS angle 80 by 50 with thickness 5 mm, 6 mm. Can you see this? 5 mm, 6 mm, 8 mm, 10 mm. Ours is IS angle 80 by 50 and 8 mm. 80 by 50, 8 mm, isn't it? അല്ലേ? തിക്നെസ് എന്ന് പറഞ്ഞാൽ 8 mm തിക്നെസ് ഉള്ള ഒരു പ്ലേറ്റ് ആണ് നമ്മുടേത്. See here, the thickness is written here. Thickness is written here, that is 8 mm. So our property, or we need to consider the elements, we need to consider whatever things are coming here. So this is ours, okay? This is the thing we need to consider. This element is ours. Understood? That is IS angle 80 by 50, 8 mm. So the gross area, see here, you can see the sectional area. Kando, idu kando, sectional area എന്ന് പറഞ്ഞാൽ in centimeter square, the sectional area in centimeter square is what? 9.78. Kando? Have you seen this? For IS angle 80 by 50 by 8, the gross area is, or sectional area is 9.78 centimeter square, which means this value, now I can say this value is what? 9.78 centimeter square. You will get this from steel table. First, from steel table, IS angle 80 by 50 by 8, the sectional area AG is equal to 9.78 centimeter square, which means 9.78 into 100 millimeter square. From here, substituting the value back over here, you will get the value for TDG, that is the design strength of the member, as 9.78 into 100, that is AG, into 250 by 1.1, you will get this value as 222.27 kilonewton. So is it okay up to here? This is the strength of the, or this much load has to be resisted by the strength. We need to design the weld for this much amount of load. So is that fine? You have this thing like this. Now you will go to the thing what you have studied before, that is the minimum size of the weld, which depends on the thickness of the member. So here the thickness of the member is what? It is given as 8 mm. The thickness of the member is 8 mm here. So from IS 800 you have, for minimum thickness of the member as 8 mm, you have up to 8 mm. The minimum size of the weld is 3 mm, isn't it? So you know how to calculate this. So you'll get the minimum size of the member as, minimum size of the thickness of up to 8 mm. The minimum size of the weld is 3 mm. So this is the minimum limit. The maximum size of the weld, you know, this portion you can see here. This portion, this is actually a 90 degree, right? You can see here, this is actually 90 degree. This one is 90 degree. But this portion, it is actually a curved one, a rounded edge, isn't it? This is actually a curved one, rounded edge. This is actually a rounded edge. This portion is rounded edge. So IS 800 tells you, or we have studied this in detail, maximum size of the weld is 3 by 4 into 8 for a rounded edge. So if you are considering here, that is 3 by 4 into 8, you will get it as 6 mm. It is given in clause number 10.5.8.2. Or if it is a 90 degree sharp edge, it is thickness of the member minus 1.5. Here the thickness of the member, this is 8 mm. This you will get it as 8 mm. So T minus 1.5, that is 8 minus 1.5, 6 mm. We need to take the smaller of this. That is, we will take 6 mm as my, or 6 mm as the maximum size of the weld. So the minimum size of the weld is 3 millimeter and the maximum size is 6 millimeter, which means I'll assume a weld size of S is equal to 6 millimeter. Have you understood how to calculate this? Because before, the last things when we have done was, it was always sharp edge. It was 90 degree edge. Here, we are using a rolled steel angle section. The edge will always be like this. That is, it will be a rounded. It will not be a curved one, a straight one. It will be a rounded edge. So if you are taking a rounded edge, the maximum size of the weld is 3 by 4 of 8. That is, you can see here in your IS 800 2007 10.5.8.2. I hope you have studied this before also. See, when the fillet weld is applied to the rounded toe of a roll section, the specified size of the weld should generally not exceed 3 by 4 of the thickness of the section at the toe. Here, definitely the area is more over here, which means the center of gravity will be somewhat near to this portion, right? Where the area is more, the center of gravity will shift toward that point, isn't it? So if I am considering, let P1 be the load transferred by the top weld of length LW1. That is, I will consider this at the top weld and this be P1, and let P2 be the weld load transferred by the bottom weld, this one, that is this I will consider as P2, that is this is P1 and this is P2, and let the center of gravity be somewhere here, the center of gravity be somewhere here, and from your steel table I will get the center of gravity. See here, you can see ഇത് കണ്ടോ, you see here, this is my unequal angle section. There is one term CXX കാണുന്നുണ്ടോ, CXX, and there is one term CYY കണ്ടോ. This is actually, if I am considering the x-axis and y-axis in this manner, this is my x-axis, sorry, y-axis, and this is my x-axis, this is my x-axis, then the center of gravity of this element, this is my L section, the center of gravity is somewhere here, the center of gravity is somewhere here, the center of gravity is somewhere here, and that is at a distance of CYY and CXX from your respective axis. So that value is specified over here. If you see this center of gravity CXX and CYY for different angle section is being provided here. See, for different angle section is provided here, and you can see for IS angle 80 by 50 by 8, the center of gravity is 2.73, this is 2.73, CXX is 2.73 and CYY is 1.24. Have you seen this? For IS angle 80 by 50 by 8, the center of gravity is 2.73 and 1.24. Kando. That is, I can write this is CXX and this is CYY. Okay, so CXX means what? It is the distance from, you can see here, this is clearly mentioned, distance from bottom of this to this much center of gravity of this element. You can see here. കണ്ടോ, ഇതാണ് CXX എന്ന് പറഞ്ഞിരിക്കുന്നത് അല്ലേ. That is the distance from bottom to center of gravity of this element, that is CXX, and that is given as, that value is given as 2.73, and that unit is in centimeters. That is, I can say here, I can say this distance, that is, if this is the center of gravity, then this distance is 27.3 mm, right? This distance is 27.3 mm, isn't it? That is from the bottom of your leg to center of gravity, that is 2.73 centimeter, that is I can write as 27.3 millimeter. Is it okay? Drawing this, you will see like this, that is P1 is acting like this, P2 is acting like this, and the center of gravity is somewhere here, center of gravity is somewhere here at a distance of 27.3 mm. Okay, now we need to find what is the value for this P1 and what is the value for P2. So the actual force I'm applying is what? That is my P, and that will be acting through my center of gravity, isn't it? The design strength is acting, always the load will be acting through my center of gravity. Before, what we have seen was, we are having a plate, and always the plate, the load will be acting through the center of gravity, and that is exactly at the center. As a result, the load which is being transferred here, will be same. The load which will be acting here and here, it will be P by 2 and P by 2, isn't it? This was what you have seen in your plate element, but in this case, the center of gravity is not exactly at the center, so the load taken by, or the load shared by this P1 and P2 will be different. This P2 will definitely be larger because the load is more shifted towards this position. So now we will see your basics in your engineering mechanics, first year TOS 1, how to find the value of P. You have the basic equilibrium conditions by, that is by force equilibrium equation, you have P is equal to P1 plus P2, isn't it? You have P is equal to P1 plus P2, which means P is what? That is the design strength. You have obtained this as 222.27 kilonewton. ഓർമ്മയുണ്ടോ അത് കിട്ടിയത്? You obtained this value as 27.2 ഇവിടെ നിങ്ങൾക്ക് ആ വാല്യൂ കിട്ടിയിട്ടുണ്ട് 27.2 എന്ന് കണ്ടോ, സോറി 27 അല്ല 222.27 kilonewton. So that is the value for P. So when you are applying here, you will get P is equal to P1 plus P2. That is your first equation. Sigma H, the horizontal sum of horizontal force, is equal to P. Now you can take the moment about this point. If I am taking the moment about the point A, P2 into this distance 80 will be there, right? With respect to A, that is in the clockwise direction, right? P2 into 80 in the clockwise direction, isn't it? This will be in equilibrium, right? I can write P2 into 80 minus P into 27, right? Moment about A, I can write P2 into 80. That's it. If I am considering moment about A, then there is one. If I am considering moment about A, there is P2 into 80, the distance, is equal to P into this distance, right? This distance is what? 80 minus 27.3. So you'll get this value of P2 as 146.42. Substituting back over here, you'll get the value for P1 as 75.81. So have you understood how to get the value for P1 and P2? That is, you'll consider the moment about any point and you'll find the value for your P1 and P2. This you have studied in your TOIS 1. Now to find the weld length, you have the equation P1 is equal to stress into area, isn't it? That is, stress is what? Fu by root 3 into gamma mw into L effective into Ks. Ks is your throat thickness. So L effective 1, that is corresponding to P1. L effective 1 is corresponding to P1. I'll get the value for my weld as 114.43. That is, I will round it to 115. And L effective 2, that is 142, 146. That is your P2. This is your P1. This value is P1. And this value is P2. Correspondingly, you will get the value for L effective 1 and L effective 2 as 115 mm and 221 mm, which means I can check the minimum lap required is 4 into size of the weld or 40 mm, whichever is more, 40 mm, but we are providing 115 and 221, which means it is safe, it is okay. So we will see the end return, how much end return is required. That is, end return is 2 into size of the weld, that is 2 into 6, 12 mm. So which means the overall length required is LW1 is L effective 1 plus 2 into 12, that is 139 mm, and L effective 2 is, sorry, L actual length, overall length required for weld 2 is L effective 2 plus 2 into 12, that is 245 mm. Hope you are clear up to here, which means
Yes, sir.
now I am going to draw this. You will get it like this. If I am going to draw this, my gusset plate is here. My angle section, I could draw it. My angle section is going like this. This is the leg of the angle. If I am taking the sectional view, I could get it like this. The gusset plate is over here. So hope you can understand this. Now the length of the weld required at the top, that is at the top, is 139 mm. The total length of the weld required is 139 mm. So that I will get it like this. This is 139 mm. And at the bottom I require 245. That is, I'll provide it like this: 245, 245 mm, and such that the required load P, that is the design strength of the load member, can be taken. So if I'm providing here, the weld will be somewhere here and weld will be here, and this was your P1 and this was your P2. And this angle, this is IS angle 80 by 50 by 8. So are you clear with this?
Yes, sir.
I understood this question.
Yes, sir.